Today we're going to learn how to measure the density of an irregular solid. We need two things in order to measure the density. One is the mass and one is the volume measurement. In order to measure the mass, we're going to use a balance. Whenever we use a balance, the first thing we want to do is make sure it's correctly zeroed. So we press the 0. This balance is zeroed, so we're ready to measure the mass of the object. We place it on the balance, and the mass is 49.38 grams. Record all of the digits that the balance displays. This balance reads to 0.01 grams. The second measurement we need is the volume of the irregular object. In order to do that, I'm going to use a method known as water displacement method. In the water displacement method, we measure the volume of the irregular object in a graduated cylinder and determine how much water it displaces. In this case, we have a 100 milliliter capacity graduated cylinder. The graduated cylinder has its smallest divisions at 1 milliliter units. Because of this, we're able to read to the tenth of a milliliter. So all of my measurements taken on this graduated cylinder should be recorded to a tenth of a milliliter. First, what I'm going to do is determine the approximate volume of the object so I know how much water to place in the cylinder. The object is somewhere between 30 and 40 milliliters. I need to cover it completely with water. I've put some green food coloring in the water so it's easier to see. So I'm going to put somewhere between 30 and 40 milliliters of liquid in the cylinder. It doesn't matter how much I put because I'm going to read the exact measurement. In order to read the cylinder properly, I need to be at eye level, and remember, I need to read it to a precision of a tenth of a milliliter. The measurement on the graduated cylinder is read at the bottom of the meniscus. This cylinder is reading 34.1 milliliters of liquid to the bottom of the meniscus. I'm now going to place the object in the graduated cylinder gently. In order to do that, I want to slide it in. The cylinder is glass. A metal object can crack it if I drop it in. Now I'm going to take the final reading after I place the object in, and the difference will tell me the volume of the object. After placing the object in the graduated cylinder, the final reading is 40.0 milliliters. The final volume reading on the cylinder was 40.0 milliliters. I need to record the final 0 because I need to read to a precision of the tenths place, regardless of whether that reading is a 0 or a digit other than 0. In order to find out how much volume of water was displaced by the object, I take my final volume of 40 milliliters and subtract my initial volume of 34.1 milliliter. So the volume of water displaced by the object was 5.9 milliliters. Once I have the mass and the volume, I can then calculate the density. I do that by dividing the mass by the volume. 49.38 grams divided by 5.9 milliliters. Our result is recorded to the number of significant figures of the measurement that has the lowest number of significant figures, which is our volume measurement, 5.9. It has two significant figures. So our result should only have two digits. So we record our density as 8.4 grams per milliliter. You have now successfully measured the density of an irregular object.